first thread in the entire multi-threading environment. Now this part is different because when you use pthreads in C or C++ inside a Linux or POSIX type of environment, you don't need to initialize the kernel. You don't need to initialize the use of threads. Okay, we'll talk about why that is the case later on, but it has to do with using the -p thread option when you use GCC to compile the program. Okay, so there's something magic happening, when you specify -p thread that changes the initialization code before main gets control. So the initialization is still there. It is just that you don't have to worry about it because the library automatically links in the initialization code. There's something in this kernel that is not really available in pthreads. For example, I have semaphores. Pthreads has a very similar concept called Mutex, okay, mutual exclusion, which is essentially a semaphore that can only have a value of 0 or 1. A semaphore is a slightly more general concept that can have integer values that are more than 1. So they are about the same. And then I have a suicide to kill a thread itself, or a thread kill to kill a specific thread. I do not have any ability to join two threads into one, because in many embedded applications, each thread will just keep going indefinitely, and there's really not a whole lot of need to join two threads back into one. But pthread definitely has the ability to do that. And here is about 2 example programs. With this microphone, the funny thing is it will pick up the door opening and closing with really good clarity. So when you guys listen to it again, you will actually hear the door opening and closing, people walking in and out. Everything that you normally will see, you will hear, will also be recorded. Because the microphone is a 360-degree microphone, it's omnidirectional, it will pick up everything in the classroom. So here's one example, which is almost useless. All it does is to initialize the main thread, which is the main program itself. And as I said a little bit earlier, you don't have to do this with pthreads because the initialization is done before main gets control. So that's one slight difference between this particular RTK and pthreads in Linux. And then this one here is a different example. In this case, I use RTK count get to basically get the RTK tick count, which is basically just an integer that gets incremented every so often. And I add 100 to that number, and then I schedule when this particular thread is supposed to wake up. It is very similar to the concept of alarm with signals, except in this case there's really no signal. The real-time kernel will take care of the timing issue related to this. So after 100 ticks of the system ticks, this particular thread, which is the only thread, the main thread, will be awakened again in order to perform whatever it's supposed to perform. Yep.
Man 3 POSIX sem_init.
So there's a semaphore too. Okay, good. And the rest of it is not really that important. It's just comparing with all the other stuff that is available. Even with an 8-bit processor running at 16 megahertz, there are actually at least 2 or 3 real-time kernels already for that particular architecture, not counting mine. So there are tons of people writing miniature real-time kernels for that sort of application, which actually makes sense because you really want to be able to write programs in a parallel manner with embedded systems. Considering this device has 48 pins, 48 general I/O pins, multi-threading is almost a necessity. All right, so that's basically it for my little real-time kernel. I just want to basically point out how similar this particular kernel is to pthreads, even though it comes from a completely different development source. So now we can go back to the discussion of Linux or pthreads, POSIX threads. I have added a little bit more to it. I cannot remember where we stopped on this topic. Can anyone remember? No? if we cannot remember, we can always just go ahead.
I thought you were on. I thought you finished 4.
I finished 4, so 5 is brand new. I just wrote this part last night. So pthread is a well-documented concept, using the man pages. So there's really no need for me to replicate, the material that is already in the man pages. But there are certain things in the man pages that I do want to point out. So when it is time to point that out, I will go to the man pages and basically highlight that portion. So 5.1 talks about how the first thread is started and how there is a hidden thread that you don't have to start. It is also automatically started. The first thread of a process, when you use pthread, is started when the process begins. This thread is started by default and therefore does not require any special considerations. Okay, so the main thread or the first thread of a particular program that is pthread enabled will start automatically. You don't need to say, I want to start a thread. It is already there to begin with. A manager thread is also created with pthreads when pthreads are used in Linux. This manager thread exists only to create and terminate other threads, and it is not the first thread. So there are 2 threads basically pre-existing before you call pthread create. Are there any questions about this? One is called a manager thread, which its only existence, the purpose of existence, is to manage all the other threads. And then the other one is the default first thread, which you can also call it the main thread, because the main function is the function associated with that thread.
So is the manager thread going to be the second thread or not necessarily?
Sorry?
The manager thread, is it going to be the second thread or is it not necessarily?
I do not know which one gets created first. Basically, there's one, when the process begins, by default, it already has one thread because there's a stack already allocated when the process starts. That will basically call the initialization code of pthread, the pthread library, which is before you get control in main. So one of those threads will basically call main and become the actual first thread, and then the other one will continue to become the manager thread. So I have no idea which one is started first, which one spins off which other one. But for the most part, you don't need any special consideration regarding the helper or the manager thread. There's no need to wait for it to die before the main thread exits. Yep.
What initializes the stack and the heap? What have you?
That's the code that gets called before main gets control. I cannot remember the name of that subroutine, but you can find it out when you use a object dump. It will basically give you the name of the subroutines, and they usually start with an underscore because those are quote-unquote hidden subroutines. Okay, let me just kind of expand a little bit more on that question. Okay, that's not what I want to do. Okay, so the question is, what kind of subroutine is called before main gets control? Is that your question? Yep.
Would strace tell you something like that, or ltrace or something like that? Would that show you the?
strace will trace all the system calls, but not the initialization calls before main gets control.
Because isn't malloc used in there? So if you use strace, you'll see the malloc calls and what have you before.
Yeah, malloc is a system call. It will eventually translate into a system call. So what we can do is, just to create a very simple program. So